Voyager 1 has spent nearly half a century sailing through the cosmic dark. Now, from more than 15 billion miles away, it's sending back something scientists can barely explain.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again, after months of spouting gibberish.
Its latest message isn't just puzzling, it is rewriting what we thought was possible. The discovery has rattled experts and cracked open a mystery no one saw coming. What could be so strange out there, so far from home? By the end of this, you might start questioning what space really holds. A strange signal beyond the solar system. Voyager 1 has been floating through interstellar space since 2012, long past the point where the sun's power can reach. No more solar winds, no more pull from our star. Just silence. Or so they thought. At first, the data coming back looked like background noise. Small fluctuations in the plasma wave readings, nothing major. But then, the patterns started. Not once, not twice, over and over. Regular pulses in the middle of what should have been random static. That's when scientists began to pay attention. Was it a technical issue? Voyager 1 had been out there for over 40 years. Its instruments were old, worn, and exposed to cosmic radiation for decades. Any number of malfunctions could explain strange readings, but the patterns were too consistent, and they kept showing up. Eventually, after combing through months of data, teams on Earth confirmed it. Voyager wasn't picking up noise. It was moving through something. A structured wave. Long, stable, and organized. Charged particles, arranged in a way no one expected to find out there. It stretched across distances we can barely imagine. This wasn't what the interstellar medium was supposed to be. Scientists had always thought of it as mostly empty. Sparse atoms, weak magnetic fields, just a quiet zone between stars. But now, with these waves mapped out, that idea no longer holds. The frequencies don't match anything tied to solar activity. These aren't shock waves or turbulence left behind by the sun. They move like standing waves, locked in place. Almost like the vibrations inside a crystal, except this one exists across millions of kilometers in space. The discovery changes everything. It means interstellar space might not be as still as we once believed. There could be larger structures out there, hidden until now. Forces linking matter across distances far beyond what we thought possible. And the clock is ticking. Voyager's power is fading. Soon, it will fall silent for good. But before that happens, it has given us something new. Something no one expected to find. A message from deep space, wrapped in plasma and silence. What lies beyond this discovery? Is this just a small piece of a much bigger pattern? If the void is not really a void, then what else is waiting out there, just beyond the reach of our understanding? The unexplained waves in interstellar space. The patterns Voyager 1 picked up didn't fade. In fact, they started raising new questions. One of the first ideas scientists explored was magnetic reconnection. Maybe these structured waves came from the remains of distant supernovae. Or maybe they formed when ancient magnetic fields collided and rearranged themselves, leaving faint signals behind. Could Voyager 1 have crossed through the long-faded ripple of a cosmic explosion? Some researchers believe these waves could be what's left of massive interstellar shocks. Not random ones, but ones shaped by the motion of gas and magnetic fields over thousands of years. Like a footprint pressed deep into soft ground and slowly covered, but never erased. Then came another idea. It was harder to ignore than many expected. What if the waves weren't shaped by nature at all? What if they were arranged? The frequency, the timing, the structure, all of it felt too specific, too intentional. Most experts still believe there is a natural explanation. But a small group of researchers has started asking whether Voyager 1 passed through something more. If there is intelligent life out there, would it use light or radio to reach across space? Or would it choose something harder to detect, something woven into the very particles drifting between stars? Voyager might have floated straight through a kind of message, a transmission buried in the fabric of plasma itself. Even if the signal is natural, it changes everything. Voyager has moved from explorer to observer, from passive recorder to silent witness. What it detected could reshape how we view the space between stars. Those waves could be shifting energy, guiding matter, or even shaping how galaxies form. And we never saw it coming. What else could they affect? Could they push clouds of gas into motion long before gravity plays its part? Could they be guiding the early steps in the formation of stars? Without us even knowing, this discovery might also shift how we understand our own neighborhood. The heliopause is no longer a clear boundary. It looks more like a handoff from one active system to another, from the sun's control to something much older, broader, and more complex. Voyager 1 is still out there, still sending data, and it just might have uncovered one of the biggest cosmic surprises we have seen in decades. Beyond the solar boundary. The ripples Voyager 1 detected suggest that the border of our solar system might not be a sharp boundary. Instead, it appears porous, alive, and in constant exchange. If plasma waves can exist out there in organized form, energy and matter could flow between the solar and interstellar realms more freely than previously believed. Could such waves also carry information? Engineers and mission planners are equally intrigued. Voyager 1's instruments are still functioning, surpassing all expectations. The plasma wave subsystem was originally meant to study planetary magnetospheres, yet here it is detecting structures in deep space with clarity it was never designed to achieve. This outcome highlights the value of long-duration missions and emphasizes how robust engineering can yield surprises decades later. Future deep space probes will surely draw lessons from Voyager's resilience and modular design. A more reflective aspect of this discovery touches on humanity's impulse to explore. Voyager 1 is a relic of an earlier era, built when slide rules and analog gauges were still the norm. It was powered by energy less than that of a household light bulb. Yet, it drifted into the void and detected something no one expected. That achievement speaks to more than just technical excellence. It reflects a deeper drive, which is the determination to reach outward even with limited tools. The universe continues to hide secrets in its quiet corners, and even older spacecraft can bring new revelations to light. This finding also reopens debates around interstellar communication. Researchers are reconsidering old assumptions. If plasma itself can carry complex information, whether that arises naturally or from some intelligent source, then perhaps we need to expand our search strategies. Communication may not occur through radio bursts or laser pulses alone. It might unfold as subtle modulation embedded in the structure of space itself. Voyager 1 may have provided the first real evidence of such a possibility. We are left to ask whether the signal it detected was created by nature or by something more deliberate. Either way, the potential implications are astonishing. Voyager finds order in the void. Voyager 1's latest revelation sparked new scientific detective work. Astronomers looked immediately to Voyager 2, which is also navigating interstellar space, but along a different path. So far, it has not detected those same mysterious oscillations. That absence suggests that the structure might be localized to the region Voyager 1 traveled through. Could orientation or perhaps sensitivity differences explain it? Perhaps Voyager 1 crossed a rare pocket of plasma with this organized pattern. This contrast has energized teams designing future missions. If those structured plasma waves extend beyond a single location, upcoming spacecraft could carry instruments tuned specifically to detect and map such structures. Meanwhile, theoretical physicists are already racing to simulate new plasma behaviors in conditions so extreme they have no Earth equivalent. Modeling interstellar turbulence, once sidelined by more terrestrial theories, is now front and center in astrophysics labs. Could these waves resemble phenomena like quantum fields or exotic states of matter thought to exist in the early universe? Some scientists propose that Voyager 1 sampled echoes of cosmic events from billions of years ago. Others imagine that these waves are woven into the architecture of space itself, bridging forces such as gravity and electromagnetism. If so, Voyager 1 may have stumbled upon a hint of a universal field, a physical pattern that underlies reality. Its instruments, though primitive by modern standards, might just have recorded part of the universe's operating system. It is striking that such a paradigm shift came from hardware designed in the 1970s. That fact reminds us of the power of endurance engineering and unexpected payoff. Scientists are now preparing for what might be the most significant chapter in Voyager 1's mission. More data may arrive before its power finally fails. They expect that Voyager could drift into another region where those wave patterns intensify. Perhaps it will encounter even more complex oscillations or higher energy zones. If such zones exist, they could significantly alter our grasp of physics. Could this be nature behaving in ways our current theories never imagined? At the same time, the search for extraterrestrial intelligence is shifting focus. If plasma can carry structured signals, maybe some advanced civilization would use plasma modulation rather than radio bursts. Could Voyager have passed through such a deliberate pattern? The possibility remains speculative, but intriguing. Resonance in the cosmic void. Although the probe's path cannot be changed, Voyager 1 continues forward on its course, driven only by past momentum and gravitational influences. Yet, the cosmos ahead is anything but static. The signals it has returned show that interstellar space is alive with secrets, not uncovered by spectacular displays, but by steady, persistent observation. Now, when scientists realized this spacecraft had detected patterns in the interstellar medium that had never been seen before, excitement swept across the scientific community. Every packet of data it beams back now carries weighty expectations. Experts from beyond traditional astrophysics have joined the effort to interpret these patterns. Plasma physicists, signal analysts, quantum theorists, even linguists are examining the data from novel perspectives, each bringing ideas about what might be encoded in these structured waveforms. At the core of this fascination lies a bold suggestion. The medium Voyager encountered may not only respond to cosmic disturbances, but also convey some form of communication. The rhythmic character of these oscillations hints at underlying rules yet to be described. What if Voyager 1 is not merely drifting through a passive void, but interacting with a form of spatial architecture? These plasma waves may not be isolated effects. They could be shaped by vast magnetic frameworks or interstellar currents that organize space on a galactic scale. This concept is increasingly accepted among specialists who propose that large magnetic fields might form filamentary or lattice-like structures across the galaxy. At defined intervals along those filaments, heightened plasma resonance could emerge. Voyager 1 may have simply skimmed one such point, and the data collected may correspond to only one tone of a much larger interstellar harmony. If more of these resonance points exist, that implies they could be arranged across space, like stations on a vast frequency spectrum. This discovery also introduces new questions about time itself in distant regions. If structures in the interstellar medium pulse in harmony with galactic rotation or cycles of star formation, then time might manifest in ways we have not yet considered. Voyager 1 has delivered perhaps the most unexpected revelation of its mission. A solitary spacecraft traveling through supposed emptiness has uncovered structure, motion, and possibly communication woven into the fabric of space itself. What began as faint pulses from beyond the heliosphere now calls for a fundamental rethinking of what lies between the stars. The hidden beat between the stars. A long-lasting wave system, stable and repeating, moving through a place thought to be chaotic and unpredictable. Some researchers are calling it an interstellar heartbeat. But what could be keeping it alive out there? To dig deeper, teams began comparing Voyager 1's readings with data from other missions. Voyager 2, although nearby in cosmic terms, didn't detect the same wave, at least not clearly. Some think its instruments simply weren't facing the right way. Others believe the wave might be moving in a narrow direction, making it easy to miss. Now scientists are reprocessing decades-old data from Pioneer 10 and 11, looking for even the slightest trace of a similar signal. Those probes didn't have the same sensitivity, but anything, no matter how faint, could help confirm the wave is real, not just a one-off glitch. There is another theory that has everyone talking. These waves may not just exist in isolation. They could be shaping the way particles travel across space, forming invisible corridors that affect their speed and direction. Could this explain why cosmic rays sometimes hit Earth with no clear pattern? Some scientists think it's possible. These waves may be acting like unseen traffic systems, guiding or slowing particles over unimaginable distances. And if that's true, what does it mean for spacecraft? Future missions might be able to use these waves the way a sailor reads the sea. They wouldn't need as much fuel. Instead, they could glide along space's own rhythm, using the natural flow to push forward. It's even being suggested that these waves could help with navigation. If you could feel the texture of space the way sailors once felt ocean currents, then maybe you wouldn't need maps. Maybe you would just need the right kind of sensor. And Voyager 1 may have already drawn the first path. Mapping the unseen. Even as momentum around the discovery continued, attention shifted toward modeling its reach. Researchers began building simulations with increasing urgency, mapping how charged particles and galactic magnetism could form regions resembling what Voyager 1 encountered. An entire framework emerged, constructing a frequency map of the galaxy. If such structures exist beyond that tiny swath of space, they might reveal a hidden landscape, one traced not by stars, but by oscillations in plasma. That ambition meets a daunting limit. Voyager 1 sampled only a slender sliver of the Milky Way. Trying to extend conclusions from its data alone feels like studying the Atlantic by examining a single drop. To widen the view, scientists turned to indirect clues. They started studying distortions in cosmic background radiation and peculiarities in signals from fast radio bursts. They even considered whether shifts in light caused by gravitational lensing could betray similar wave structures. Each approach aims to cross-reference data and reveal whether Voyager's finding was rare or part of a larger, galaxy-wide pattern. Attention then shifted to possible roles these structures may play in star formation. Gas clouds collapse into stars when conditions align. If coherent wave patterns thread through those regions, they might serve as triggers, nudging clouds to condense in ways we never imagined. Voyager 1 could have passed through the echo of such a process, some ancient remnant of stellar creation carrying forward in plasma. Small surprises emerged next. Physicists examining the waveform noted something unexpected. It held a consistent phase. Solar plasma tends to fluctuate wildly. This did not. The structure persisted in time and space with steadiness. That implies the presence of a stabilizing architecture, perhaps magnetic fields with unusual alignment, or something entirely unknown. Such coherence under diffuse conditions has no clear analog in conventional plasma physics. That exercise in coherence raised a further question. How ancient might this structure be? Some researchers speculated it arose directly from processes in the galaxy's earliest era, maybe tracing back to events that shaped its spiral arms or magnetic skeleton. If so, those waves carry age beyond anything humans can track. They could serve as an electromagnetic fossil, a relic of galactic growth held not in stone, but in motion, carried through space. The implications grow deeper still. What if the interstellar medium is not passive at all, but actively preserving history? As archaeologists read layers of sediment, future explorers could one day read these waves as records. A nearby supernova might have sent ripples through that medium. A passing black hole could have bent fields in a signature pattern. Voyager 1 may have crossed through the first readable echo of ancient galactic events. In that sense, the discovery shifts from physics into historiography. Space might hold archive material, written not in physical artifacts, but recorded in waves. Voyager 1's fleeting encounter could be the first footstep on a new path, one that leads us toward reading cosmic memory instead of simply measuring it. By the time these thoughts crystallized, the tone of the discussion had already changed. Voyager 1 no longer seems like a probe. It has become a silent messenger from an archive we barely knew existed. Scientists around the globe are now asking different questions. They are thinking as if the interstellar medium holds structure, history, and perhaps meaning. And they are designing tools to find it again. Traces of life in interstellar silence. The silence of space can deceive. Voyager 1 proved that. For decades, the interstellar medium was believed to be too thin, too frozen, and too chaotic for anything to survive in or move through with purpose. It was the kind of environment that erased things, not preserved them. But now, some scientists are starting to question whether that idea was ever really true. What if, hidden within that hostile space, there are rare pockets of order? What if the waves Voyager 1 recorded aren't just background patterns, but signs of stability, maybe even protection? This is where the discussion begins to shift from physics into biology. Some researchers now wonder if life, small, tough, and silent, could drift between stars. Microbes sealed in icy shells, spores trapped in bits of rock. For years, the theory of panspermia suggested life might travel this way, but the odds always seemed impossibly low. Now, there's a new angle to consider. Could the waves Voyager found help protect or even guide those tiny travelers? And it goes deeper. If these waveforms have been around for thousands of years, they may hold records of events long past, exploding stars, shifting magnetic fields, supernovae that left scars across space. The plasma might still carry the echoes. Some researchers now think Voyager didn't just move into a new part of space. It might have wandered into a kind of archive, a record not written in stone or ink, but in the slow, pulsing rhythm of interstellar waves. There is another theory pulling attention. When experts looked closely at the waveforms, they noticed something unusual. The pattern wasn't entirely random. It wasn't perfectly regular either. It sat in the middle, structured, almost as if it were carrying information. This kind of signal is known as low entropy, and it shows up in systems that are built to store or share messages. Could the universe be transmitting something, not with beacons or broadcasts, but through the medium of space itself? New instruments are now being developed to answer that question. Telescopes that can pick up the faintest ripple, simulations that try to mimic the conditions Voyager moved through. No one knows what might come next. But for the first time, scientists are listening in a way they never have before. Seeing space in a new light. From one end of the world to the other, Voyager 1's latest finding has caused a shift, not just in science, but in how people see space itself. Some researchers have begun to suggest that the space between stars might be more than just distance. There could be a hidden rhythm in it, a kind of structure that moves with purpose. And that idea has spread far beyond science labs. Painters, writers, filmmakers, and even philosophers have started to respond to it, each in their own way. What if the universe isn't just silence and chaos? What if it's working together, piece by piece, in ways we've never understood? That question hits especially hard when thinking about our place in all of it. Could everything really be random if space itself has patterns? For years, people asked why no alien signal had ever reached Earth. Maybe we have been listening the wrong way. Voyager 1 didn't hear a voice or a broadcast. It picked up something more subtle. A pattern. A structure. Not fully artificial, but not entirely natural either. What if intelligent life somewhere else figured out how to use space itself to pass on information? Not through light or radio waves, but through the medium that surrounds every star and every planet? Some universities are now working on this theory. New projects are combining plasma science, artificial intelligence, and astrobiology to dig deeper into Voyager's data. Even experts in quantum theory and dark matter are joining the conversation, wondering if this discovery hints at more than we ever imagined. None of this is certain yet, but it is enough to spark new research and reframe old assumptions. The public interest has only grown. Schools have started updating their science programs to reflect this evolving view of space. Museums are building displays that turn Voyager's data into sound and light, helping people experience what cannot be seen. Voyager 1 is no longer just a machine drifting in space. It has become a bridge between science and imagination. But what's most striking is how quietly it all started. The signal Voyager detected didn't announce itself. There was no flash, no sudden spike, just small shifts in frequency, barely noticeable. It took patience and focus to catch it. And that patience may have just changed everything we thought we knew about the universe. Energy in the silence. Energy. That's the word now drawing attention in the wake of Voyager 1's latest data. Not communication, not a signal, but energy. Could the space between stars actually be storing power? The idea sounds impossible at first, but the readings from Voyager suggest something different. As mentioned before, the plasma around the probe wasn't behaving like scattered debris. It moved in a rhythm, held together by invisible rules. That kind of motion doesn't just happen without a reason. Some researchers are asking a bold question. If those patterns are steady and repeatable, could they be harnessed? Could future spacecraft collect power from these waveforms the same way solar panels pull energy from the sun? Experiments have already begun. In controlled environments, low-energy plasma has been shown to release small amounts of electricity when captured and tuned correctly. On Earth, these currents are weak and not very useful. But in the vacuum of space, with less interference, and with the right tools, even a small charge might be enough to keep an onboard system alive, or guide a probe farther than any engine ever could. Then comes the stranger part. Some believe that the structure inside the plasma might be doing more than just vibrating. It could be encoding something, not in ones and zeros like a computer file, but through patterns that stack and shift, similar to how musical harmonies build on top of each other. Each layer might carry a different kind of data, some quick, some slow, all hidden inside the pulse. Could this be why the signal felt so organized? Could it be that what Voyager found wasn't just random motion, but something closer to a layered message? No one is claiming to have answers, but one thing is becoming harder to ignore. The region Voyager passed through may not have formed by accident. It shows signs of order, of design, whether by nature or something else. The effect is the same. It opens a door we didn't know existed. The discovery was never loud. It didn't light up sensors or flood data centers. But that might be the most unsettling part, because whatever Voyager 1 crossed into, it had been waiting there the whole time. Calm, steady, and quietly structured, just beyond the reach of everything we thought we understood. Plasma waves and the shape of the unknown. The strange part isn't just what Voyager 1 found. It is what the discovery might be leading us toward next. There are now plans for missions that would retrace Voyager 1's route with better equipment. These future probes would not just confirm what Voyager picked up, but try to map it in detail. Instead of simple readings, we could soon have full three-dimensional models of these plasma structures, showing how they stretch, twist, and interact across light years of space. If that happens, we might finally understand what causes them, where they came from, and how they might evolve over time. But even as the world looks ahead, Voyager 1 keeps drifting further into space. Its power is fading slowly, and sooner or later, its instruments will fall silent. And yet, the impact it has made may last for centuries. That one unexpected reading, those strange plasma wave patterns, has shifted how science approaches the unknown. It didn't just add to what we know, it changed what we are allowed to ask. Physics textbooks will be rewritten. Theories once seen as too speculative are now back on the table. New research centers are forming around a question that didn't even exist a few years ago. And all of this came from a spacecraft no longer in contact with Earth in real time, and operating on technology far older than the smartphones in most people's pockets. Think about what that means. If a spacecraft so old and so distant could pick up something no one predicted, what else have we missed? What might still be out there, waiting to be found by something that simply lasts long enough? Voyager 1 was never supposed to find this. Its mission was never designed to detect strange patterns in the plasma beyond the solar system. But it kept going. And in doing that, it showed us that the space between stars may not be empty after all. Each signal Voyager sends back now carries more weight than ever. Researchers are scanning every bit of data, trying to figure out what the spacecraft stumbled into. Some believe this could point to an entirely new way of understanding galactic space, not just as a backdrop, but as something active, something organized, maybe even something that carries meaning. No one knows yet what the final answer will be. But one thing is certain: Voyager 1 did not just extend the reach of science, it pulled back a curtain we didn't even know was there. If this made you pause and think, let us know by liking the video. And if you are wondering what else Voyager might still uncover, subscribe. You won't want to miss it. Thank you for watching. See you in the next video.